Hey everyone, today's lesson is lesson 116 and it's finding common denominators to add, subtract, and compare fractions. So a couple of lessons ago we talked about LCM or least common multiple. That set you up for this foundation. So that is really what we're going to practice using today in order to do this. So finding those common denominators, because you can't do any combining or comparing of fractions unless they have a common denominator. You can't do anything until that happens. So let's just kind of get rolling with this. We have a couple of examples that we'll go through. First of all, our learning targets for today are to compare fractions with different denominators. So when you're given two different fractions, what do you need to do in order to compare them? And then also add and subtract fractions with different denominators. So obviously with both of these saying different denominators, what you need to do first is make them have the same denominator. So finding a common denominator, that's your first step before you can do any of this work. So our first example, we're just reviewing basically what I just said. We're going to use least common multiple to do this. Here's just something to look at before we do an official example. So we have 2/3 and 3/4. And I don't know why. I always like to rewrite these next to the given fraction right now. So you can see right here we have those two fractions. I like to write the new fractions right next to them, kind of on the outside. So maybe that's just part of me being like a visual learner. I like to see them right next to it. So I don't know. Let's just take a look here. I'm going to get ready to set up some new fractions right next door. I'm looking at my denominators right now, and I have 3 and 4. So 3 and 4, I'm going to start by thinking about the multiples of 3. So this is where I would actually, like back a couple days ago, where we actually wrote out the multiples. If that helps you to actually physically write them out, do that. Write out physically write out on a piece of paper the multiples of 3, and then do the same for the number 4 and find the least common multiple. I'm going to do that, but basically talk through it. So I'm thinking about the multiples of 3. I have 3. And as I'm doing this, I should pause and say this. As I'm doing this, as I'm listing the multiples of 3, also in the back of my mind, I'm thinking, when am I going to come across one of these multiples that I'm going to say that is also a multiple of 4? So I'm thinking about 3 and 4 kind of at the same time. So my multiples of 3 are 3. 3 is not a multiple of 4. I have 3 times 2 is 6. 6 is not a multiple of 4. 3 times 3 is 9. 9 is not a multiple of 4. 3 times 4 is 12. 12 is a multiple of 4 because 3 times 4. I mentioned this in my least common multiple video, but oftentimes, if you're not sure where to start, you can multiply your two denominators that you're given, and that will always give you a common denominator, not necessarily your least common denominator, but it'll give you one. So in this case, it is our least common multiple or our least common denominator to use. So I'm going to start by rewriting my denominators as 12. There we go. So now I have a place to go. This is almost like a proportion. So I'm looking at, well, how do I get from 4 to 12? What did I multiply that by? 4 times 3 is 12. So let's see if I can write this in, just for the sake of looking at these notes later. Well, 4 times 3 is 12, so I must do the same thing to my numerator. Up here, 3 times 3 is, 9. So that's my new fraction. 9/12 is my new fraction that I'm going to look at, and I'm going to do the same thing over on the left here. So 3 times what is 12? Well, 3 times 4 is 12. And whatever I do to my denominator, I will do to my numerator. So 2 times 4 is 8. So they're not even asking us to compare these two fractions, but if they were, now we have 8/12 and 9/12. And once they have a common denominator, it's really easy to compare them and decide which one's greater. So of course, in this case, this would be greater. 9 out of 12 is greater than 8 out of 12. So now that we've kind of laid this foundation and looked at this, let's go ahead and look at an actual example. Oh, I like this one because it's very real world appropriate. This happens all the time. I've said this before, but I often consider taking videos of myself from my kitchen because there is so much math in cooking, you guys. There's tons of fraction work, decimal work, converting measurements, ratios, a huge thing that I come across in cooking. So let's read this and I'll explain a little bit further. If you want a challenge, just pause the video right here. I encourage you to read this on your own. Try this problem completely on your own, and when you're confident with your answer, unpause the video and you can watch as I solve. So, in one of Katie's cookbooks, a recipe for salsa calls for 3/4 of a cup of chopped fresh cilantro. Yum. A salsa recipe given to Katie by her friend calls for 7/8 of a cup of fresh cilantro. Which recipe calls for more cilantro? So just like any math problem, it's really important that we're looking here at what exactly are they asking us. They're not asking us to add these together. They're not asking us to convert anything. They're just asking us to really compare the two. Which one is bigger? Whose recipe has more? So let's just start by writing out the fractions that were given. Katie's recipe calls for 3/4 of a cup, and her friend's recipe calls for 7/8 of a cup. Now, when we're asking which one has more, we're comparing. Right now, we don't have common denominators. That's our first step. We need to find a common denominator so we can easily decide which one is more. So just like I did earlier, I always set it up right next to it. If you have another way, if you want to completely write these underneath, like down here, do that. That's fine. This is just kind of how my brain works. So I'm starting to consider 4 and 8 now. So I'm going to start thinking about my multiples of 4 and also considering what is a multiple of 8. This is going to be one of those cases, and you may have just kind of noticed this already, but I'm going to talk through it anyway. Sometimes one of the numbers that you're given, one of the denominators that you're given, will actually be a multiple of the other. So for example, in this case right here, 8 is a multiple of 4, or you could say 4 is a factor of 8. One of them, the smaller one, goes into the other one evenly. So in this case, we can't use 4 as a common denominator. This is actually something important to consider. When you're looking at two fractions, start there too. So look at the two fractions that you're given and say, is there one of these denominators that can be common for both of them? So as I consider 4, can 4 be my common denominator for both of these? Well, no, because 8 can't go down into 4. It can, but that's a fractional part, and we're not doing that. So 4 won't work, but 8 sure will. 8. So 8 is a multiple of 4. I'm just going to, I didn't even need to rewrite that fraction, but I just did just because. So if 8 remains my denominator, my fraction stays the same. If I turn my denominator over here for my fraction of 3/4, I turn the denominator into 8. Now I have to do that thing where I'm asking myself, well, 4 times what is 8? And it's times 2. And I must do the same to my numerator on top. 3 times 2 is 6. I'm crossing out the old ones just to get them out of my face, so I can see which ones I'm comparing. So I have 6/8 and 7/8. So going back to my original question, what exactly are they asking me? 7/8 or 6/8, those aren't answers. Those are just like, that's important information that tells you what your answer is. So ultimately they're asking, which recipe calls for more cilantro? And it's the second one here, that 7/8 fraction. Whose recipe was that? Her friend. Which recipe calls for more cilantro? I would say her friend's recipe. Oof, this isn't turning out very well. Yikes. Her friend's recipe. You could also include that 7/8 of a cup of cilantro. You could say something like that, but okay. Let's move on to example number 2. Here we don't have a story type problem or a word problem. We actually have just a basic addition problem. So go ahead and pause this video, give it a try, and when you're confident in your answer, unpause it for a solution and to check your work with mine. So 1/2 plus 1/4. As I'm looking at this, the first thing I'm going to ask myself is, looking at these two denominators, is there one of them that can be the common denominator for both of them? So meaning, if there's a smaller and a larger one, can the smaller one go into the larger one? Or is the larger one a multiple of the smaller one? Is the smaller one a factor of the larger one? It's a lot of wordiness around this, but here's what I'm thinking. Well, I'm looking at 2 and 4. 2 can't work because 4 can't go down into 2, but 4 can work for both of them. 4 is a multiple of 4. Of course, 4 times 1 is 4. And 4 is also a multiple of 2. 2 times 2 is 4. So I'm going to rewrite this problem using 4 as my new denominators. So I don't know. I'm just going to rewrite the entire problem right here using 4s as my denominator. Now, this fraction correlates with this right here. The denominator for that one is already 4. My fraction's not going to change, okay? But this one right here, if I change my new denominator to 4, I'm asking myself now, how do I get from 2 to 4? 2 times what? 2 times 2 is 4. So whatever I do to my denominator, I must do to my numerator. So again, times 2, come on, 1 times 2 is 2. So now I have a new addition problem. When you add fractions, your denominator stays the same. Don't touch it. Don't all of a sudden make your denominator 8 over here because you added them together. Don't do that. Your denominator stays constant. It stays the same. So part of your answer, boom, it's done. You just carried it over. Now all you have to do is add your numerators together. So we have 2 plus 1, and that's 3. And your answer is 3/4. All right. Last example. Subtracting. I don't know why, but subtracting just seems like so much harder than addition, and it's not. It's not that scary. So taking a look at this now, we have mixed numbers. So mixed numbers, of course, they go hand in hand with fractions. Anytime we do fractional work, we should be ready to do mixed number work as well. They're part of the same family. So we have 3.5 minus 1 1/6. We cannot touch this problem until we have common denominators. So we're going to begin this work by just looking at the fractional parts. There's a chance that we're going to have to look at our whole number parts and regroup them. So I would say borrow, but the new math term is regroup. So we're going to borrow from them or regroup them to help our fractions out. I'm not going to go there yet. There's a chance we might need to, but let's just take a look and see what we can do with the denominators that we're given. So even though these aren't linear right now, they're stacked on top of each other. Let's take a look at these two. We have a 2 and a 6. So out of 2 and 6, first of all, let's consider this. Is there one of those numbers that could work for both? Sometimes it's a no, and sometimes it's a yes. So first of all, 2 won't work for both of them because 6 can't come down into 2. But let's look at 6. Is 6 a multiple of 2? If it is, we can use it for both. 6, of course, is a multiple of 6. 6 times 1 is 6. So now we're asking, is 6 a multiple of 2? Well, 2 times 1 is 2. 2 times 2 is 4. 2 times 3 is 6. Yes, we can use it. So I'm going to try to zoom in a little bit. It's hard for me to write small with this stylus pen. Let's see. I'm going to rewrite the fractional parts over here to the right. We decided to go with 6 as a common denominator. So this fraction actually doesn't change at all, but I'm just rewriting it because I'm going to rewrite the other one. So I like consistency. So that one stayed the same, but this one's going to be different. So now I'm thinking, I don't really have room to draw this all out, so I'm going to talk through it, and I hope that works out okay. We're asking ourselves, how do we get from 2 to 6? 2 times what is 6? Well, we just said 2 times 3 is 6. So whatever I do to my denominator, I must do to my numerator. 1 times 3 is 3. We're ready to do some subtracting. Now, just like with adding, when you add or subtract fractions, your denominator stays the same. It stays constant. So our denominator is already done. Now we have just our numerators to think about. We have 3 minus 1, and that is 2. And now that our fractional part is done, we're going to subtract our whole number parts. It's important that you do fractions first, you guys. I think out there at some point, some of the 5th graders were a little bit confused and they thought you could move in any way, like you could do your whole number parts first. Don't do that. You have to do fractional parts first because there are circumstances where you have to tap in and borrow from these whole numbers. So always do your fractional parts first. Once that's complete, now you can look at your whole number parts. We have 3 minus 1, and that's 2. So now I ask you, take a look at my answer. Is that complete? No, it's not. We can reduce that. So 2 and 2/6, we can reduce that fraction, of course. 2 and 6, those are both even numbers. We can divide them each by 2. With fractions, with mixed numbers, any type of work like that, if you can reduce, the answer is yes. Always reduce. Always, every single time. It's best math practice. So our whole number will stay the same as 2, but our fraction, we're going to divide the numerator and denominator both by 2, and we get 1/3. I had to think about that for a second. I almost said 1/2. Oh, come on. 1/3. Okay. I want to say that was our last example. Yep, it was our last example for today. If you need any clarification, go ahead and rewatch parts of this video. Otherwise, you'll find the notes attached in Google Classroom as well as your homework assignment. So thanks and have a great day.